What if I told you that the last time your luxury car broke down, the incredibly expensive part your mechanic replaced wasn't actually broken at all?
Yeah, that is an incredibly common scenario.
Right. I mean, welcome to another deep dive. Today we are looking at a multi-million-dollar industry problem that's known as the parts guessing game. You bring your car in with a glowing dashboard light, a mechanic plugs in a scanner, pulls a code, and just, starts throwing your money at new sensors and modules, just hoping one of them makes the warning light turn off.
And it leaves owners feeling completely helpless. I mean, they pay for a repair, drive off the lot, and like 3 days later, that exact same warning light chimes again. Because the underlying problem was never actually solved. The shop merely treated a symptom.
Well, we are putting a stop to that today. We are building the ultimate playbook for navigating complex vehicle maintenance, specifically focusing on modern luxury vehicles.
Which is so needed right now.
Definitely. And our roadmap for this comes from an extensive stack of resources and technical playbooks provided by J&N Auto Clinic. They're an independent, highly specialized Mercedes-Benz repair center operating in the Boston area.
Right.
So our mission today is to look at their engineering philosophy to understand why your modern car behaves the way it does, why traditional mechanics often get it completely wrong, and how to finally settle the debate over original factory parts versus cheaper aftermarket alternatives.
True mechanical knowledge changes the entire ownership experience. When you understand the architecture of these vehicles, you stop operating out of fear. You know the right questions to ask, which, prevents you from financing someone else's on-the-job training with your car.
Which nobody wants to do. So let's start with the most feared category of breakdown. We are talking about electrical issues.
Oh, yeah. The absolute worst.
According to the J&N Auto Clinic data, these are the faults that completely defy logic. Your car works perfectly on Tuesday. On Wednesday, the infotainment screen goes black and the power windows stop working. On Thursday, everything is fine again. And then on Friday, you walk out to the driveway and the battery's completely flat.
Yeah. To understand why that happens,
Yeah.
we have to look at how a modern luxury car is actually wired. Historically, automotive electrical systems were, well, they were binary and linear. You had a battery, a physical switch, a wire, and a headlight.
Pretty simple.
Exactly. If the wire snapped, the light went out. The diagnosis was simple. You trace the wire, find the brake. But modern luxury cars, especially a Mercedes-Benz, do not operate like that. They use something called a CAN bus system.
A CAN bus system.
Yeah, which stands for Controller Area Network.
Okay, let's unpack this. So rather than physical wires directly running from a switch to a motor, it's more of a computer network.
Yes. Think of it as an entire localized internet running inside the chassis of your car. You don't just have one central computer. You have dozens of microcomputers, called modules, distributed throughout the vehicle.
Oh, wow. Dozens.
Dozens. You have a module for the engine, a module for the transmission, one for the anti-lock brakes, and even modules inside the doors to control the windows and locks.
That's a lot of computers in the doors alone.
Right, and these modules constantly communicate with each other over the CAN bus network using rapid pulses of voltage.
That sounds incredibly efficient, but it also sounds like a recipe for a localized glitch to cause absolute chaos.
I mean, diagnosing a modern Mercedes sounds less like traditional wrench turning and more like IT troubleshooting a complex smart home.
That is a very good way to put it.
Right, like where a glitch in the smart fridge somehow makes the garage door open. If they're all sharing the same communication lines, how does a fault in one obscure module affect a completely different part of the car?
Well, what's fascinating here is that it comes down to data packets. Let's say the anti-lock braking module needs to know how fast the wheels are turning so it knows when to engage.
It relies on a wheel speed sensor. But those voltage pulses, the actual data being sent across the network, require near-perfect electrical conditions. If there is a microscopic amount of corrosion on a ground wire, or a slight degradation in the wiring harness.
The voltage drops.
Exactly. And when that voltage drops, the data packet gets corrupted or dropped entirely.
So the braking module doesn't receive the message, it panics, and it throws an error code to the dashboard.
Precisely. And this is where the generic code reader completely betrays the car owner. You take the car to a general mechanic. They plug in a $50 scanner they bought at an auto parts store.
Right. We've all seen those.
The scanner pulls the code and says, "Error. Wheel speed sensor." The mechanic replaces the sensor, charges you $400, and sends you on your way.
But the sensor was never the problem. The sensor was sending the data perfectly fine.
Exactly.
The issue was, like, a tiny piece of corrosion on a ground wire halfway across the car that was degrading the voltage of the signal.
And that is the essence of the parts guessing game. The stored fault code on a generic scanner often only points to the system that was affected by the communication breakdown, not the root cause.
So the new sensor doesn't fix the corroded ground wire.
Right. So a few days later, the exact same error code returns.
Wow. Okay, so what about the dead battery scenario, the parasitic drain where the car just dies overnight? How does the network cause that?
That involves a mechanism called the sleep state. When you turn off your car, take the key out, and lock the doors, the car doesn't actually shut down immediately.
It doesn't.
No, the modules go through a sequenced shutdown process. They communicate over the SAN bus, confirming that systems are secure, and then they essentially go to sleep to preserve battery power.
Okay, I'm following.
But if a single module gets a corrupted signal, say, the door module falsely believes the door latch is still open because of a faulty microswitch, it stays awake.
And because it stays awake, it keeps pinging the network, which keeps other modules awake.
It becomes a cascading failure. 50 computers sitting in your driveway actively running all night long.
Oh, that's wild. So by morning, your battery's completely drained.
Yep. And a generic mechanic will test the battery, see it's dead, and sell you a new one. A week later, that new battery is dead too because the underlying sleep state issue was never diagnosed.
That really highlights the danger of shops that guess. And the documentation from J&N Auto Clinic emphasizes a completely different approach. They mandate a definitive diagnosis process starting at $150, using dealer-level proprietary equipment before any parts are ever quoted.
Yeah, they do that because finding the root cause requires live data analysis. A master technician isn't just reading static stored codes. They are looking at the live voltage sweeps of the network while the car is running.
Oh, so they're watching it in real time.
Exactly. They are monitoring the sleep state sequence with an oscilloscope to see exactly which module is refusing to power down. They are looking for pending false errors the car is experiencing but hasn't yet triggered a dashboard light for.
Spending a diagnostic fee up front to get definitive proof of the mechanical failure makes total sense.
Right.
It acts as an insurance policy against a massive, unnecessary parts bill.
Absolutely.
But, okay, this creates a serious logistical headache. If my luxury car has a parasitic drain and the battery is dead in my driveway, or it's experiencing a random no-start condition, I have to get it to that specialist. My first instinct is to call a tow truck, drag it onto a flatbed, and haul it to the shop.
Towing a vehicle with an intermittent electrical fault is often the worst thing you can do for the diagnostic process.
Here's where it gets really interesting. I have to push back on that.
Okay, go ahead.
If the car won't start, I have no choice, right? And honestly, don't you want the car sitting on a lift in a fully equipped shop with perfect lighting so the technician can pull it apart?
Well, if we connect this to the bigger picture to understand why a tow truck is problematic, we have to look at the physical reality of an intermittent electrical fault. Think about a loose pin connector inside a wiring harness, or a wire where the insulation has rubbed away, causing it to randomly short out against the metal frame of the car.
Right.
These physical faults are highly dependent on their immediate environment. Temperature plays a massive role. Thermal expansion when the engine bay is hot might cause two wires to touch.
Oh, I see.
Yeah, and then when the car cools down overnight, the metal contracts, the wires separate, and the car functions perfectly again.
Oh, I see where this is going. The classic syndrome where the car makes a terrible noise or refuses to start, but the second the mechanic looks at it, it behaves perfectly.
It happens all the time. When you drag a luxury car onto a flatbed tow truck, you are changing its environment. You are vibrating the chassis. You are jostling the suspension.
Right.
Very often, the physical movement of the tow is just enough to nudge that loose pin connector back into place or separate the shorted wires.
You are essentially tampering with the crime scene before the detective arrives.
That is a perfect way to conceptualize it. The fault temporarily disappears. The mechanic at the shop plugs in their equipment, but there is no live data to capture because the car is functioning normally in that exact moment.
So they have nothing to go on.
They end up relying on the static, stored codes, which we already know are notoriously unreliable for root cause analysis.
That completely flips the script on how we handle breakdowns. And it explains a major component of the J&N Auto Clinic playbook.
Yes, it does.
According to the sources, they provide 247 emergency mobile service. They deploy master technicians directly to a customer's driveway or even an office parking garage to perform these deep electrical diagnostics on-site.
Because mobile diagnostics preserves the fault environment. The technician brings the dealer-level diagnostic equipment directly to the car while it is actively exhibiting the symptom.
So they see it exactly as it's failing.
Right. If the car won't start because it sat in the freezing cold overnight, the technician reads the live data in the freezing cold. They can see exactly which module is failing to communicate under those specific thermal conditions.
It also highlights the extreme value of specialization. I noticed the J&N playbook places heavy emphasis on the technician's credentials, specifically having Mercedes-Benz master technician training.
That's crucial.
It really implies that a generalist mobile mechanic with an iPad just isn't going to cut it.
A general mechanic might know how an internal combustion engine works fundamentally, but a specialist knows the specific topography of a particular brand's CAN bus network. A master technician has seen the failure patterns 100 times.
You know the quirks.
Exactly. They know that on a specific chassis code, a leak in the sunroof drainage channel tends to drip water directly onto the rear SAM module, which is the signal acquisition module.
Oh, wow.
So when they see a seemingly random cluster of taillight and fuel pump errors, they don't start testing the fuel pump, they go straight to the trunk to look for water damage.
That kind of pattern recognition is invaluable. It also means that as the car owner, I have a responsibility here too.
You do.
If the environment is that critical to the diagnosis, I need to start gathering data the moment the car acts up.
Absolutely. You become the primary observer. Does the screen glitch out only when the heater is running? Does the car struggle to start only after it rains?
Or did a cluster of warning lights appear 3 days after you had a windshield replaced?
Yes. You don't need to turn a wrench, but providing that specific environmental data to a master technician gives them a targeted starting point for their live data analysis.
Okay, so the master tech arrives in your driveway. They use their specialized equipment and your environmental observations, and they definitively track the fault to a specific failing control module.
The guessing game is over.
The guessing game is over. Now we arrive at the most painful part of luxury car ownership, paying for the fix.
Yeah, that's always the tough part.
And this is where we have to tackle the dilemma of OEM versus aftermarket parts.
Right. So OEM stands for Original Equipment Manufacturer. These are the parts engineered to the exact, precise specifications dictated by the factory that built your car.
Got it.
Aftermarket parts are alternatives produced by third-party companies. They are engineered to fit a wide variety of vehicles, and they are aggressively marketed because they are significantly cheaper up front.
I am going to play devil's advocate here because the price difference is staggering.
It is.
I hear this argument all the time in automotive circles. People say aftermarket parts roll off the exact same assembly lines in the exact same factories as the OEM parts. The only difference is that the factory stamps a Mercedes logo on one box and marks the price up by 300%.
I've heard that so many times.
Though if that is true, why on earth would I pay the OEM markup? Isn't it just a tax for the logo?
It is a very pervasive myth, but it fundamentally misunderstands automotive manufacturing and quality control. Yes, a third-party factory might produce both the OEM sensor and the aftermarket sensor, but the difference lies in the engineering tolerances and the quality control grading.
What do you mean by grading?
Okay, when Mercedes contracts a factory to build a mass airflow sensor, they dictate an incredibly narrow tolerance window. The sensor's voltage output must be flawless.
Okay.
When a batch of sensors comes off the assembly line, they are tested. The A-grade sensors, the ones that hit that microscopic tolerance perfectly, get the OEM stamp.
I see.
The sensors that fall slightly outside that perfect window but are still technically functional become the B-grade parts. Those are often packaged and sold on the aftermarket.
Oh, so what does this all mean? They might come from the same building, but they're not the same quality.
Exactly.
But if the aftermarket part still functions, does a tiny variance in tolerance really matter that much?
An older mechanical car, maybe not. In a modern luxury car running a complex CAN bus network, it matters entirely. Think of your car's interconnected sensor network like a professional symphony orchestra. Every module and sensor has to play its part with perfect timing and pitch.
So dropping an aftermarket sensor into the mix is like hiring a violinist who plays the right notes, but plays them a quarter step flat and half a beat behind everyone else.
Exactly. The violinist is technically playing the song, but the timing of the entire orchestra is thrown off. If you install an aftermarket sensor that sends a signal back to the engine computer at 4.8 volts instead of the required 5.0 volts, The computer interprets that slight variance as an error.
Oh, wow.
It attempts to compensate by adjusting the fuel-to-air mixture, which causes a slight misfire, which triggers the check engine light.
And suddenly you are right back to the parts guessing game. It's like buying a cheap gas station phone charger that eventually fries your expensive phone battery. You didn't save money, you just delayed a bigger bill.
You did. And this raises an important question about the hidden danger of cheap aftermarket parts. If an aftermarket part fails early, or its loose tolerances cause a communication error across the CAN bus, you are going to pay the mechanic's labor rate twice.
Hmm.
You pay them once to install the cheap part, and you pay them a second time a month later to take it out and install the correct OEM part.
Which perfectly explains why J&N Auto Clinic takes such a strict stance in their playbook. According to the sources, they default exclusively to genuine OEM parts for all critical systems. Sensors, electronics, engine management components, cooling systems, and seals.
They are doing it to guarantee that the repair integrates seamlessly with the car's computer network and to ensure the repair remains warranty safe.
Right.
A specialist understands that a low upfront cost on a part usually results in high long-term costs in diagnostic labor. They will occasionally use aftermarket parts if a customer insists, but typically only for non-critical components on much older vehicles where warranty and network integration aren't really factors.
I understand the engineering logic behind OEM parts now. The symphony orchestra analogy makes it very clear why those tolerances are non-negotiable. But we really cannot ignore the financial reality.
That's true.
OEM parts are wildly expensive.
Mm-hmm.
If I'm insisting on factory parts, aren't I basically paying dealership prices? Why wouldn't I just take the car to the dealership if I'm buying their parts anyway?
That is the most crucial financial insight in this entire playbook. It requires a total reframing of how you view a repair bill.
Okay, how so?
The cost of a repair is split into two columns, right? Parts and labor. The dealership charges an absolute premium on parts, but they also charge an astronomical premium on their hourly labor rate.
That makes sense.
That labor rate pays for their massive overhead. The glass showrooms, the espresso machines in the waiting area, the army of service advisors.
Right, you are paying for the real estate, not just the repair.
Exactly. And the J&N Auto Clinic data points out a massive financial advantage for the consumer here. Owners who use highly qualified independent specialists frequently save 50 to 70% on the labor rate compared to the dealership.
Wait, really? 50 to 70%? That is a massive reduction in the overall bill.
It is. And that labor savings is the secret to affording proper maintenance. By utilizing a specialized independent shop, one that has the master technicians and the dealer-level equipment, you cut your labor costs drastically.
So you then take those savings and reinvest them into purchasing the high-quality, genuine OEM parts.
Exactly.
That is a brilliant strategy. You aren't compromising on the hardware that keeps your car's complex network functioning, but you are stripping away the inflated dealership overhead.
Right. You get maximum reliability, seamless module communication, and warranty protection,
Yeah.
all while tightly controlling your overall expenditure.
It is the definition of strategic vehicle ownership, and it demands transparency from your mechanic. A trustworthy specialist will always be able to explain the why behind their parts recommendation.
They should be able to articulate why spending an extra $100 on an OEM sensor today will save you $600 in diagnostic labor 6 months from now.
Let's pull all of these elements together into a cohesive strategy for the listener. If you drive a modern luxury vehicle, you are driving a highly complex, rolling computer network.
A local internet on wheels.
Right. So when a warning light comes on, or the car refuses to start, you do not let a generalist plug in a cheap scanner and start guessing with your money. You demand a definitive diagnosis using live data analysis and full system scans to find the root cause, not just the symptom.
Furthermore, you recognize that moving a broken car can erase the physical evidence of the fault. You leverage specialized mobile diagnostics to evaluate the vehicle in its natural environment, utilizing the expertise of a master technician who actually understands your car's specific network architecture.
Finally, when it comes time to repair the fault, you avoid the false economy of cheap aftermarket electronics. You seek out the 50 to 70% labor savings offered by an independent specialist, and you use those savings to insist on genuine OEM parts, keeping your vehicle's intricate symphony of sensors perfectly in tune.
You are no longer at the mercy of a dashboard warning light.
Exactly. You have the knowledge to advocate for your car and your wallet.
You do. But as we finish up here, there is a broader implication to all of this engineering complexity that I think is worth pondering.
Oh, I like where this is going. What's on your mind?
Well, we have spent this time detailing just how reliant these luxury vehicles are on strict voltage tolerances and flawless communication across dozens of microcomputers. It begs a serious question about the ultimate lifespan of modern automotive design.
Where do you see this heading?
Think about automotive history. For a century, a car's lifespan was dictated by its physical mechanics. A car went to the junkyard when the engine block cracked, the piston rings failed, or the steel chassis rusted completely through.
Mechanical degradation was the ultimate killer.
Right. But today, we are looking at vehicles where a microscopic variance in a single module sleep state can render a 2-ton machine entirely undrivable.
So you are asking what happens to these networks decades down the line.
Precisely. If a modern luxury car requires absolute software harmony to even start its engine, will the physical hardware of the car eventually outlast its software's ability to communicate?
Oh, wow.
20 or 30 years from now, will we see junkyards filled with vehicles that have pristine engines and perfect leather interiors simply because a single obsolete microchip deep inside a door panel finally forgot how to talk to the rest of the network, and a replacement can no longer be manufactured?
That is a staggering thought. The physical machine surviving, but the digital brain permanently crashing. It really drives home the reality that maintaining a modern car is no longer just about changing the oil and checking the brake pads.
No, it is about actively preserving a delicate digital ecosystem. The definition of a mechanic is really evolving into a network engineer. The rules of longevity have fundamentally changed.
That is an incredible note to end on. So the next time you walk out to your car and hear that polite little warning chime, you know exactly what is happening beneath the surface. Don't panic, don't guess, and demand the data. Keep questioning the world around you, and thank you for joining us on this deep dive.